basic trigonometry and its applications in physics, especially in mechanics, that we are going to discuss in this short video. See, trigonometric functions are defined in a right triangle. Okay, now see here we have marked an angle theta. Now see the trigonometric ratios are sine theta. Sine theta is defined as the ratio of opposite side to the hypotenuse. See, this is angle theta. Which one is the opposite side? See, opposite to theta we have side y and the hypotenuse is r. So, sine theta is defined as opposite side by hypotenuse, that is y by r. And it is also the reciprocal of cosecant theta. Okay, cosecant theta, or cosecant theta is 1 by sine theta. Now, the second ratio is cos theta. Cos theta. Children, this cos theta is actually cosine theta. Sine theta and cosine theta are co-functions. Now, see, cos theta is actually, it is defined as the adjacent side divided by hypotenuse. Which side is adjacent to theta? That is x. Hypotenuse is again r. Now, cos theta is also the reciprocal of secant theta. Secant theta. Okay, or secant theta is 1 by cos theta. Now, sine theta and cosine theta are co-functions. Now, secant theta and cosecant theta are also co-functions. Now, the third ratio is tan theta. Okay, tan theta. Okay, it is actually tangent theta. Now, tan theta is opposite side divided by adjacent side, and it is also the reciprocal of cot theta, or we can say cot theta is 1 by tan theta. Now, tan theta and cot theta are co-functions. Now, see, the most important property in a right triangle is the Pythagoras theorem. What is Pythagoras theorem? See, here we will have cx square, okay, plus y square. Okay, this is equal to r square. That is the mathematical form of the Pythagoras theorem. Now, see, let's divide this equation throughout by r square. Okay, so here we will get x by r whole square plus y by r whole square. Okay, then r square over r square, that is 1. Now, see, what is x by r? X by r we have, it is cos theta. So, x by r whole square is actually cos square theta. And what is y by r? That is sin theta. Y by r whole square will be sin square theta. And on the right side we have 1. See, this is an important result. Okay, sin square theta plus cos square theta equal to 1. Now, see, if you divide this equation throughout by cos square theta. See, first term cos square theta by cos square theta, that you will get 1. Okay. The next will be sin square theta by cos square theta. See, what is, see, this tan theta. Tan theta here, this tan theta is actually tan theta. This is equal to, see, tan theta is y by x. It can also be written as sin theta divided by cos theta. Sin theta by cos theta. So, if you divide this equation throughout by cos square theta, first term will be cos square theta by cos square theta, that is 1. And second term will be sin square theta by cos square theta. Sin theta by cos theta is tan theta. So, sin square theta by cos square theta will be tan square theta. Okay. So, 1 plus tan square theta, this is equal to 1 by cos square theta. See, what is 1 by cos theta? See, cos theta is 1 by secant theta. So, 1 by cos theta will be sec theta. Here we have 1 by cos square theta. That will be sec square theta. Okay, sec square theta. Okay, this we will get if we divide this equation throughout by cos theta. Okay, now see, this we will get if we divide this equation throughout by cos square theta. Now, if we divide this equation throughout by sin square theta, what do we get? See, cos square theta by sin square theta. What is cos theta by sin theta? See, it is actually cot theta. See, here we can write cot theta. Cot theta, see, tan theta is 1 by cot theta. So, cot theta will be 1 by tan theta. And it can be written as, see, tan theta is sin theta by cos theta. So, cot theta, that is the reciprocal of tan theta, it can be written as cos theta divided by sin theta. Cos theta by sin theta. Now, let's divide this throughout by sin square theta. So, first term will be cos square theta by sin square theta. That is, cos square theta by sin square theta will be cot square theta. Okay, cot square theta. See, now sin square theta by sin square theta, that is 1. Let me write that 1 here. So, 1 plus cot square theta. And on the right side, 1 by sin square theta. See, sin theta is 1 by cosecant theta. So, 1 by sin theta will be cosecant theta. Here we have 1 by sin square theta. It will be cosec square theta. Okay, cosec square theta. Right, cosec square theta. Okay, now 1 plus cot square theta. This is equal to cosec square theta. Right, that is another important result. Okay, this is another important result. So, we will have sin square theta plus cos square theta equal to 1, 1 plus tan square theta equal to sec square theta, and 1 plus cot square theta equal to cosec square theta. Now, see, what is sin A plus B? See, A and B are two angles. A and B are two angles. Okay, instead of theta, here I am writing one angle is A represented by capital A and the second angle is capital B. Okay, what is sin A plus B? It is actually sin A cos B, okay, plus cos A sin B. Sin A cos B plus cos A sin B. Okay, now see, what would be the case if A equal to theta and B is also equal to theta? If A equal to theta and B is also equal to theta, see what would be the result? Sin of theta plus theta. What is theta plus theta? Sin of theta plus theta will be sin 2 theta. Okay, so sin 2 theta. Sin 2 theta equal to. See, the first term will be sin theta cos theta. And the second term will be, see, this B we have to replace by theta. This A is also to be replaced by theta. So, sin theta cos theta, here also sin theta cos theta. So, sin theta cos theta plus cos theta sin theta. Cos theta sin theta is nothing but sin theta cos theta. Okay, so we will get sin theta cos theta plus sin theta cos theta, that is 2 sin theta cos theta. 2 sin theta cos theta. Okay, that is sin 2 theta. Okay, sin 2 theta. Now, see, what would be the case if it is sin A minus B? The only difference is, see, if it is A minus B, here also instead of plus we will have to make it minus. Means sin A minus B will be sin A cos B minus cos A sin B. Okay, now let's consider the cosine function. See, cos, okay, cos A plus B, cos A plus B. You know what is cos A plus B? It is actually cos A cos B, okay, minus sin A sin B. Cos A cos B minus sin A sin B. Okay, if it is cos A, let's put A equal to theta and B is also equal to theta. Then theta plus theta, that will be cos 2 theta. Okay, cos 2 theta. Cos 2 theta equal to, A is theta, B is also theta. So, cos theta into cos theta, that will be cos square theta. Okay, and sin theta into sin theta, that is sin square theta. Okay, sin square theta. So, cos 2 theta is actually cos square theta minus sin square theta. Okay, now what would be the case if it is cos A minus B? See, if it is cos A minus B, if it is A plus B, here we will have negative sign. Okay, if we have a negative sign here, see, here it will be positive. Okay, it will be positive here, right? Okay, this is the case. Okay, right. Now, here we have cos 2 theta as cos square theta minus sin square theta. Now, see, we know that sine square theta plus cos square theta equal to 1, the most important result in trigonometry. Okay, so you can replace this sine square theta as 1 minus cos square theta. Okay, if you replace this sine square theta as 1 minus cos square theta, you will get another expression for cos 2 theta, that is 2 cos square theta minus 1, 2 cos square theta minus 1. Okay, and this cos 2 theta can also be expressed as, okay, can also be expressed as 1 minus 2 sine square theta, 1 minus 2 sine square theta. Okay, now we have got sine a plus b, sine a minus b, cos a plus b and cos a minus b. Now what would be tan a plus b? Tan a plus b. See, this is tan a plus b. Okay, tan a plus b. This is actually tan a plus tan b. Okay, and 1 minus tan a tan b, 1 minus tan a tan b. Okay, now what would be tan 2 theta? Means we have to put a equal to theta and b is also equal to theta. So tan 2 theta means a is to be replaced by theta and b also to be replaced by theta. Then tan theta plus tan theta, that will be 2 tan theta. Okay, so 2 tan theta divided by 1 minus tan square theta, 1 minus tan square theta. Now see, this sine 2 theta and cos 2 theta can also be expressed in terms of tan theta. Okay, see, what is sine 2 theta? Sine 2 theta, okay, sine 2 theta, this is in terms of tan theta, that is 2 tan theta over 1 plus tan square theta. Okay, sine 2 theta equals 2 tan theta divided by 1 plus tan square theta. Okay, then what is cos 2 theta? Cos 2 theta, this is 1 minus tan square theta. Okay, 1 minus tan square theta divided by 1 plus tan square theta, 1 minus tan square theta divided by 1 plus tan square theta. Okay, now children, you should know see values of these functions for some standard values: 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. What are the values of sine and cosine functions for these angles? If you get the values of sine and cosine functions for these standard angles, you can easily find the values of other trigonometric functions also. Let's see. Now see here, see, this is 0 degree, okay, 0 degree, then 30 degree, then 45 degree, okay, then 60 degree and finally 90 degree. Okay, now here we will have the values of sine theta and here we will have the values of cosine theta. Okay, cos theta. Now see, this is actually, see, ratio by 2 by 2 by 2 by 2 by 2. Okay, now here we have root 0 by 2, this is root 1 by 2, root 2 by 2, this is root 3 by 2, this is root 4 by 2. Okay, see, it isn't increasing order 0, 1, 2, 3, 4 like that, and we have a common denominator, that is 2. See, what is root 4? That is 2. 2 over 2 will be 1, means sine 90 is 1. Okay, sine 60 is root 3 by 2. Root 2 by 2 is actually 1 by root 2. You can write this 2 as root 2 into root 2. So 1 root 2 from the denominator and numerator we can cancel. What remains? 1 by root 2. Okay, root 1 is 1 itself. So this will be 1 by 2. And here we have 0 by 2 means 0 only. Okay. Now see, this cosine function will be, values of this cosine function will be in the reverse order. Means cos 0, that is root 4 by 2. Okay, this is root 3 by 2, and here we will have root 2 by 2, and here we will have root 1 by 2, and this is root 0 by 2, root 0 by 2. Okay, now see, as the angle increases like 0, 30, 45, 60, 90, as the angle increases, sine function also increases. Okay, but when the angle increases from 0 to 90 degree, cosine function decreases. Children, not only the cosine function, all trigonometric functions starting with C will decrease as theta increases from 0 to 90 degree. See, trigonometric functions starting with C means cosine theta, cosecant theta and cot theta, okay, will decrease as theta increases. The other three functions means sine theta, secant theta and tan theta will increase as theta increases. Now children, see how do we use these trigonometric functions in see motion related topics, means kinematics. See, in kinematics we will have to analyze graphs, position time graph, velocity time graph, acceleration time graph, like that. Children, see, from any graph you will have to determine only two quantities. What is the physical quantity represented by the area under the graph, and what is the physical quantity represented by the slope of the graph. Slope of the graph. Children, see, in mechanics, velocity time graph means velocity is plotted along the y-axis and time along the x-axis. Displacement time graph means displacement along y-axis, time along x-axis. Velocity displacement graph means velocity along y-axis, displacement along x-axis. Means first quantity will be plotted along the y-axis and second quantity along the x-axis if not specified otherwise. Okay. Now see, the area, the physical quantity represented by the area. Okay, area under the graph. Area under the graph is always y into x, means quantity along the y-axis into quantity along the x-axis. Means what would be the physical quantity represented by the area under velocity time graph? Velocity time graph means velocity along y-axis, time along x-axis. So quantity along the y-axis is velocity, quantity along the x-axis is time. So velocity into time, that will be displacement. Okay, so area under the velocity time graph will give you the displacement. What would be the physical quantity represented by the area under acceleration time graph? Acceleration along y-axis, time along x-axis. So the area will be acceleration into time. That is nothing but a change in velocity. It is not the velocity, it is actually the change in velocity. Area under the acceleration time graph. So from a graph we will have to determine only two quantities. The quantity represented by the area under the graph, and the next is the quantity represented by the slope of the graph. Children, only a straight line graph will have a constant slope. What does it mean? See, a straight line graph will have a constant slope. Now see, we have, see, this is y-axis and this is x-axis. Okay, and suppose this is the graph. Okay, the graph is a straight line and it will have a constant slope, means slope of the line at this point, at this point, at this point, at this point are the same for a straight line graph. Now see, another shape that we see commonly come across, that is the parabola. Okay, now see, this is the parabola. Okay, now any graph other than the straight line graph will have different slope at different points. Okay, see, the slope of this parabola at here and at this point are different. See, the straight line graph will have a constant slope. Everywhere on the line the slope is constant. And what is that slope? That slope is actually, see, if this angle is theta, then slope equal to tan theta. See, that is where we will have to use the tangent function. Okay, application of trigonometry. So the slope of a straight line will be tan theta, where theta is the angle made by the line with the positive direction of x-axis. Now see, what do you mean by the positive direction of x-axis? See, suppose this is the x-axis and see this is the line. Okay, then see this is the positive direction of x-axis and this angle, say this is theta, that is the angle made by the line with the positive direction of x-axis, and this is the angle made by the line with the negative direction of x-axis. See, we have to take the angle made by the line with the positive direction of x-axis, and the tangent of that angle will give you the slope of the graph. Okay, slope of the graph. Now, see what would be the physical quantity represented by the slope of a graph. Okay, slope of a graph. Now, see the physical quantity represented by the slope of the graph. Okay, slope. Okay, if you find the slope of a graph, the quantity that you will get, that is delta y by delta x. This delta represented by small triangle stands for small change. So, small change in the quantity along y-axis by small change in the quantity along x-axis. See, I have told you, see the velocity time graph, the first quantity is velocity, second quantity is time. First quantity will be plotted along the y-axis, second quantity along the x-axis. So, velocity time graph means quantity along the y-axis is velocity. So, delta y will be change in velocity. And delta x will be change in time. Change in velocity by change in time means delta v by delta t, that is acceleration. Means the slope of the velocity time graph will give you acceleration. What would be the physical quantity represented by the slope of displacement time graph? Means displacement along the y-axis and time along the x-axis. So, displacement time graph, see the slope of that graph will give you change in displacement by change in time, that is velocity. Okay, now see slope equal to delta y by delta x and slope of a line that is given by tan theta. Now see, for any graph other than straight line will have different slopes at different points. This is a parabola. How do we find the slope of this graph? See, everywhere, see it will be making different angles with positive direction of x-axis. See, here time is plotted along the x-axis. Time is plotted along the x-axis. So, as time increases, see the angle made by the graph with the positive direction of x-axis increases. Children, I have told you, when theta increases, all trigonometric functions starting with c means cos theta, cosecant theta and cot theta will decrease. The other three trigonometric functions will increase. Means as theta increases, tan theta will increase. Okay, so here we have a parabola as the graph. So, theta increases. So, tan theta increases. So, this graph is having an increasing slope. Increasing slope. Slope increases with the time. Suppose this is the position time graph. So, the slope will give you change in position by change in time. Means displacement by time. That is velocity. Thus, if this is a position time graph, slope will give you the velocity, and this graph has an increasing slope, means the body is moving with increasing velocity or the body is accelerating. Now see, the parabola can be, see this is a straight line graph, okay, this is a parabola, okay, this is parabola, right, this is parabola, okay, let it be here, parabola, okay, this is a straight line graph, okay, this is a straight line graph, okay, let it be here, okay. If you find the area of a graph, you will get the quantity y into x, quantity along the y-axis into quantity along the x-axis, and if you find the slope of the graph, you will get delta y by delta x, change in the quantity along y-axis by change in the quantity along x-axis. Now see the parabola can be like this also. See, this is y-axis, this is x-axis, and see the parabola is like this. Okay. Now see the parabola is like this. Okay. This is x-axis, this is y-axis. Now see, initially the angle made by the parabola with x-axis is more or maximum. Okay. See, as we go forward or as we move towards right, see the angle made by the parabola with the positive direction of x-axis goes on decreasing. As theta decreases, tan theta will decrease. Or this parabola has a decreasing slope. Now, if this represents the position time graph of a body, slope will give you the velocity. Here we have a decreasing slope. So, velocity will decrease or this body is undergoing deceleration. Okay. Now, children, see, the question may be like this. Okay. This is the position time graph of a particle A. Okay. And this is the position time graph of a particle B. Okay. Position time graph of particle A is inclined at an angle 30 degree with the positive x-axis. Okay. And position time graph of particle B is inclined at an angle 60 degree with the positive direction of x-axis. Okay. Position along the y-axis and time along the x-axis. Okay. Now the question is, what is the ratio of the velocities of the two bodies? Means you have to find the velocity of A divided by velocity of B. Okay. Here we have position time graph. If you find the slope, you will get change in position by change in time, delta y by delta x, that is velocity. So, velocity of the particle A is slope of the position time graph. Slope is equal to tangent of the angle made by the graph with the positive direction of x-axis. Here it is 30 degree. So, it will be tan 30. Okay, tan 30. And see, velocity of B will be tan 60. Okay, tan 30 or tan 60, which will be of higher value. As theta increases, all trigonometric functions starting with C will decrease. But here we have tangent function. When theta is more, tan theta will be more. So, tan 60 definitely will be greater than tan 30. Okay. And tan 30, how do you get tan 30? It is actually sin 30 by cos 30. You know, tan 30 is actually sin 30 by cos 30. Okay. Here we have time along the x-axis. Okay. Now, what is tan 30? Tan 30 is actually 1 by root 3 and this is root 3. Okay. So, this will be 1 by 3. 1 by 3. Okay. If these two lines represent the position time graph of two particles A and B. Okay. Now, children, see, we have got this one. See, velocity of A divided by velocity of B will be 1 by 3. Okay. Now, suppose this is the velocity time graph of a particle. See, it need not be B because here we have only one particle. Okay. Now, see, this velocity time graph is a straight line. Means it will have a constant slope. What is the slope of the velocity time graph? Means velocity along the y-axis, time along the x-axis. So, it will be delta v by delta t. That is acceleration. Acceleration is constant. So, here the body is moving with a constant acceleration. As the velocity time graph passes through origin, initially when t equal to 0, velocity equal to 0, our body starts from rest. What would be the acceleration? See here, acceleration is actually slope that is equal to tan theta. Okay, here theta is equal to 60 degree. Here we have theta equal to 60 degree and that is root 3. Okay, what would be the displacements in a given interval of time? You can see S equal to ut plus half at square as the velocity time graph passes through origin, initial velocity u equal to 0. So, ut 0. So, it will be half, okay, acceleration a t square. Okay, and this is equal to half, then root 3 into, suppose you want to find the displacement say in 3 seconds. So, it will be 3 square, or you can find the displacement in any given interval of time.